Okay, girls, we're going to be having a look at product rule today. We have to multiply probability, whereas yesterday we added probability when we had questions that involved or. All right. So today we're going to be looking at events where there are more than one object involved, and that's the scenario where you're going to multiply the probabilities. So, for example, in question example 12a, it says find the probability of rolling a double six on two dice. So as we know, the probability of rolling a 6 is 1 over 6, and probability of rolling 6 on a second die is also 1 over 6. So multiplying those two gives you 1 over 36. But again, we want to utilize the new symbols that we've been learning so far. So what we want to do is write probability of getting a 6 and getting 6 again on the second die, which is equal to probability of getting a 6 times probability of getting a 6, okay? You don't have to write times in between. If you write them together, that means you're multiplying them. And then you write 1 over 6 times 1 over 6, which is equal to 1 over 36, okay? All right, let's apply the same thing for the second example. It says the probability that an archer will hit a target is 7 over 8. Find the probability that the archer will hit the target twice. So once again, let's set this up. So probability of H for hitting, and then hits the target twice, so that means another H, is equal to probability of hitting times probability of hitting, which in this case is just 7 over 8 times 7 over 8, which is 49 over 64, which you can't simplify, so that'll be your answer. All right, let's do the same thing for the second part. So if it says miss the target twice, that means you would write probability of M for missing again, and then that would just be the same thing, okay? The probability of missing would be 1 over 8 because it's 7 over 8 for hitting. So that's your answer here. Now, the question that I really wanted to go through was example 13. Let's have a look. Marion buys 5 tickets in a raffle in which 95 tickets are sold altogether. There are 2 prizes in the raffle. What is the probability of her winning both first and second prize? Okay, so to start this off, she bought 5 tickets and there are 95 tickets altogether. So the probability of her winning, W for winning, the first prize, I'll put a wonder for first prize, would be 5 out of 95, okay? Now, for the second prize, the chance of her winning the second prize, it's not going to be the same number because if she won the first prize, that means she's got 4 other tickets left that she has a chance of winning. And instead of 95 tickets now, there'll be 94 because 1 has been won from 95. So these are the 2 numbers that you now need to multiply, okay? And as a symbol, it'll be like this. Now I'll just write the numbers, okay? Okay, and that is equal to 2 out of 893. All right. Now, let's have a look at the second part. Now, this is a tricky question and I actually got it wrong the first time. Let's read the question carefully. It says, what is the probability of winning neither prize? Now, we can't just do 1 minus that, okay? This is not the answer to that because not winning both of the prizes does not mean the same thing as neither prizes, because not winning both prizes could mean you win the first prize, but you don't win the second prize. Okay, that's not the same thing as neither. Neither means you don't win the first or the second prize. So keep that in mind. So in order to do this question, we can't just do one take away that. It's not a complementary event of that. What you need to do is actually calculate the probability of not winning. Let's do that first. Probability of not winning the first prize is opposite of that, which would be 90 over 95. Yeah, because 95 take away 5 is 90. Now, to get the probability of not winning the second prize, okay, what you want to do, let's look at a scenario first of winning the second prize if you don't win the first prize. The chance of you winning the second prize if you don't win the first prize is 5 tickets out of 94. Does that make sense? Because remember, Mary bought 5 tickets and she didn't win anything in the first time. But in the second time, she now has a chance of winning a second prize from her 5 tickets she bought out of 94. Because it's out of 94 because the first prize has been won by someone else. So there are 94 tickets left out of 5 tickets she's got for her to chance to win the second prize. So from here, the chance of now not winning the second prize either is 1 take away 5 out of 94, which is 94 take away 5, 89 over 94. So these two numbers are what you multiply to get the probability of not winning either. So as my final answer, let's write it out. P that and neither 1 over 893. Okay, all right, so I really wanted to go through that. Okay, all right, so let's have a look at question C now of example 13b. That's not so bad. Let's see. It says, let's have a look at the question. What is the probability of her winning at least one of the prizes? So at least one of the prizes. I could write this as a simple like this. So this means she wins more than one or equal to one. So one of the prizes. How would I do that? Here is the technique that I want you to take away from this. If the question says at least of something, that is the same thing as one takeaway not. Okay, so what I'm trying to say is if you do one takeaway, the probability of her not winning anything gives you the probability of her winning at least something. Okay, so all you need to do in this question is just do one takeaway. So instead of not, I would actually put in this case neither. All right, so you just have to use that number, which is equal to, all right, does that make sense? Okay, because if you do one takeaway neither, that gives you all the numbers where she could win both or just one of the prizes. Okay, so let's have a look at example 14a. Sorry, B. A bag contains 3 red, 4 white, and 7 blue marbles. 2 marbles are drawn at random from the bag without replacement. Remember the word without replacement means you're taking one out and then you're taking another one out without putting the first one back in. Find the probability that the marbles are red and white. All right, so as soon as you see the words 2 marbles, that's a multi-stage event because you're doing one thing after another. And if you see the word without replacement or replacement in general, you know it's a tree diagram question. There are 3 colors, so let's start with 3 branches. And then let's label the colors. So that's your first pick, and because it says 2 marbles are drawn, we need to draw another branch. Okay, and writing these letters again in the same order. Oh, sorry, this should be B. My bad. All right, now let's write all the probability. Red is obviously 3 out of the total, which is 14. White is 4 out of 14. I won't simplify the numbers. I'm just going to use these numbers. Okay. Now for the second pick, if you chose red in your first pick, obviously you won't have 3 red anymore. You will have 2 reds out of 13 now because you've taken one out from the first pick. The number of white marbles will stay the same, 4, but still going to be out of 13. It's going to be out of 13 for this one as well. And the same number of blue marbles because you didn't choose blue in the first pick. Now, in this scenario, you've chosen white. So the number of red marbles will stay the same, but still out of 13. Picking white, then another white. So instead of 4, I'll have 3. And the blue marbles will stay the same. with this one, if you chose blue, your red marbles will stay the same. Your white marbles will also stay the same, but your blue marbles will go by 1. Okay, so we got this. So once again, don't forget to now, once you've done all that, write all the outcomes. So we've got RR, RW, RB, WR. We've got that. This is where the product rule comes in. To get the actual number for red, you've got to multiply the two numbers attached to it. All right. I'll do the numbers later. Let's look at the question before I spend my time going through all that. It says, find the probability the marbles are red and white. So we're looking at red and white, this one, but it can be in any other order. You can have white and red. Any other RWs? Nope, that's it. So that means you need to get these two numbers and then add them up. That's where the addition rule comes in. So red, white, that's these two. So 3 out of 14 times 4 out of 13. Let me figure out what that is in the calculator, the above. So the probability is now this plus that, okay, which is 12 out of 91. Okay, so that's where product and addition rule comes in, which you've already been doing from last year, but now we've just made it official. Okay, all right, so now let's have a look at question 5. Okay, just a slightly different type of question, just as a guide. The probability of rain in any day in May in each year is given by 3 over 10. Our school holds a fete on a Sunday in May for 3 years running. Find the probability that it will rain during 2 of the fetes. Okay, so with this one, girls, the way to set it up is if you've got 2 branches, because you can either have rain or not rain. Okay, and the key word here is it says the fete runs for 3 years running. So what you got to do is actually draw. So this is your second year. And you have to draw another one because that's your 3rd year. Okay? Once you've listed that out, the chance of raining, as it says, is 3 over 10. That means the chance of not raining would be 7 over 10. But with this one, the chance of raining and not raining is always going to stay the same throughout. So it's not like that question. We have to take away 1. The numbers will stay the same. So R will always be that, N will always be 7 over 10, so on. N would be 7 over 10, R would always be 3 over 10. I'll just complete this for you and then you can try the rest out because you get the idea, okay? That's all I wanted to show. Okay, so what they're asking for is probability that will rain during 2 of the fates. So it won't be this one because that's 3 rains. We want this one, RRN. We also want this one because it's got 2 R's. We've also got an RR. Okay, so basically get the numbers for these 3 and add them up. All right, so those examples should be enough to get you through those 2 exercises. Give them a go and let me know how you girls go. All right.